Okay, to do difference of squares, you have to have a few things. One, you have to have a subtraction sign. And you have to have what's called perfect squares. So you need to know your perfect squares. So you need to have perfect squares. So let's look at our first problem we have here. So 16 a perfect square and 9 a perfect square, they are. As long as we have even exponents, those are perfect squares. And we have a subtraction sign. So to do these problems, all you do is create your two parentheses and we fill in the blanks. Plus minus is what we put in each of those. It doesn't matter what they are, it's just always plus minus. So we take the square root of 16, which is 4. The square root of h squared is just h. The square root of 9 is 3. The square root of a squared is a. And then we just write it twice. And this is our answer factored. So let's look at our next problem right over here. Is this a perfect square? Is this a perfect square? They both are, and it's a subtraction sign. So I'll put my parentheses, plus minus, always plus minus. 11 is the square root of 121, and 4 is 2 and b. So we just recopy that, and we have our answer of the perfect squares. Sometimes when you do these, you end up with more than one. So let's look at this. Is this perfect square? It's an even exponent, and this is a perfect square. So I go parentheses, plus, minus. And now the square root of b4 is actually b squared. The square root of 16 is 4. So I copy the same thing. Now, because this problem has a subtraction sign in perfect squares, we have to do it again. Now, the b squared plus 4 doesn't because it's not a subtraction sign, but this one is. So I'm going to do that one twice. And once again, plus minus. The square root of b squared is just a b, and the square root of 4 is 2. And because none of these are perfect squares, this is our final answer. So now let's look at this problem. I'm looking for, right there I have a greatest common factor, which happens to be 3 and g. So when I factor out that, I get 9g squared minus 1. And then you check in parentheses. Well, in the parentheses, we have perfect squares. So I have my 3g as part of my answer, but then I have my two parentheses because it's difference of squares, plus minus, and that becomes 3g1 and 3g minus 1. And so my answer ends up being this entire factoring. So we're looking at first greatest common factor. So we're always looking for the greatest common factor, and we have a 5 and an x. So if I take out the 5 and the x, I'm left with x to the 4th power minus 9. Then you check parentheses, and in this case, this is a difference of squares. So I still have my 5x, but I have my two sets of parentheses now, plus minus. And I split the exponent, and I take the square root. So I split the exponent and take the square root. Now this one looks like it, but 3 is not a perfect square, so our answer ends up being that. So now we're looking at this problem, and it's subtraction and see if they're perfect squares, and they are. So I'm going to do my parentheses, plus minus. And that square root is 25, and that square root is x squared. And so 25 x squared. So this one has a subtraction sign, so I'm going to have to check it. This is the difference of squares also, so I keep my 25 plus x squared. But then I go parentheses, and plus minus. So it becomes 5x, 5, and x. And so my answer ends up being all of these factors.